Hello everybody once again, and I hope you know me by now. I'm Dr. Andrius Grabauskas, a member of InfoRec, where we analyze how Industry 4.0 impacts management practices, how it impacts economics, and we do these lovely routine seminars, webinars about various different topics, and we invite many different scholars from all around the world. And today I'm very delightful to say that we have a real treat for you. It is Professor Barış Tan who's going to be speaking, and he's a professor of operations management and industrial engineering at Koç University in Turkey. His expertise are in design and control of production systems, supply chains, management, stochastic modeling. He has many degrees in many different fields like electrical and electronics engineering from Boğaziçi University. He also studied industrial and systems engineering, manufacturing systems, and he even got a Ph.D. from operational research from University of Florida. So really a really competent person. So I'm really delightful to listen to what he has to say. And please, Barış, take it away. The floor is yours.
Thank you, Andrius, for the introduction. Today, I would like to talk about a more general topic related to Industry 4.0. So the topic has been around for a long period of time, and all the manufacturers, all the companies are interested in creating value. So I am going to talk about the ways manufacturing companies can create value by using technology. So let me start by giving you information about how I structured this talk. This talk is structured in two parts. In the first part, I'm going to talk in general why we are talking about value creation with Industry 4.0, what are we talking about, and how we can create value by using Industry 4.0. So this is a kind of a general intro. I'd like to introduce my research topics in recent years related to Industry 4.0. Basically, I am going to talk about data-driven performance evaluation and control of production systems. And also, I'm going to talk about cooperative networks and business models. I'm not planning to go into the details of these topics, but I am going to use them as examples of ways how Industry 4.0 can be used to create value for the companies. While the title of this talk is Creating Value for Manufacturers with Industry 4.0, first I should mention that manufacturing today adds the least value in a value chain. So it's kind of a surprising fact to start a talk about manufacturing in this way, but it is observed in industry that this, which is referred as a smile curve, many companies create value along the value chain in many different activities, from R&D to branding to design to distribution, marketing, sales, and after sales service. The manufacturing part here, if you look at the total value created in a product delivered to the customers, manufacturing is the one that creates the least value. But regardless of this fact, increasing this value is obviously quite important, because the value added can be increased in many different ways. At the same time, I need to emphasize that Industry 4.0 can add value in all of these parts, from concept R&D to branding to design, distribution, marketing, sales, and after sales service. But today's talk, I'm going to focus on the effect of Industry 4.0 in manufacturing. The other parts are obviously affected by the technological changes that are introduced by Industry 4.0. Now, the concept itself, all of us are quite familiar with it. The technological advances affected manufacturing, and the values from the invention of the mechanical looms in the Industrial Revolution to the assembly lines and by using the programmable logic controllers. So if you call them as the first, second, and the third Industrial Revolution, what we are talking about with the fourth Industrial Revolution is based on using all the advanced technologies in a more effective way. The term itself was introduced at a meeting of a World Economic Forum, and actually around that time, many countries also introduced their own initiatives to increase value created by manufacturing by the means of advanced technology. So if you look at many different countries, different terms are being used, from Smart Nation in Singapore to Made in China 2025 in China, to Catapult in United Kingdom. Germany, Lithuania, Turkey, they are using the same Industry 4.0 as the umbrella term for many activities and initiatives of using technology to create value. Related to that, there are many topics are also being used, like this cyber physical systems, industrial internet, cloud manufacturing, intelligent manufacturing. So all of these initiatives are actually to increase the competitiveness of manufacturing firms by increasing their ability to create more value by the means of technology. Now, when we are talking about creating value with Industry 4.0, we need to separate this into two. For example, if you are producing infrastructure technologies that are used by the others that will help them to use these technologies, that is also one way of creating value. So it is expected that all these infrastructure type of technologies related to Industry 4.0 will reach close to 100 billion euros of business in the next 5 years, and it is increasing by 6 to 7%. So, for example, if I look at this picture, Germany is actually creating a lot of value for their manufacturing firms by using Industry 4.0 as a platform to sell technologies related to Industry 4.0 to other countries, while the other countries' main interest has been so far using these technologies or buying these technologies to create a little bit more value. So there can be two distinct ways of approaching value creation. So how to create value with Industry 4.0 is essentially related to the question of how to create value for any kind of business. So if I simplify the value creation, you can say that you can create value either by transformation or improvement. So in other words, when we talk about transformation, we are talking about coming up with new business models or coming up with new products and services, new processes. When we are talking about improvement, we are talking about improving productivity, improving products, improving processes, and improving the customer service. So basically, when we are talking about creating value, these are basically possible ways of creating value. So when we are talking about creating value with Industry 4.0, we should ask the question of how can we generate new business models? How can we create new products and services? How can we create new processes and improve productivity, products, processes, and customer services by using Industry 4.0, Industry 4.0 or by Industry 4.0? What we really mean is by using the technologies that are introduced within the framework of Industry 4.0. Now, in the Industry 4.0 discussion, the technologies are usually more discussed or are discussed in more detail compared to the questions of how and why these technologies are needed. So the technological advances allowed us to use mobile devices, Internet of Things platforms, location detection, cloud computing, robotics, big data analytics, advanced algorithms, and so on. All these technologies are available, and the companies, manufacturing companies, are investing in these technologies, or generating or creating these technologies. But the basic question is how to create value with these new technologies. So that is basically a critical question for manufacturers. Otherwise, if you invest in these kind of technologies and if you cannot create more value with these new technologies, the return on investments will not be realized. So basically, these how and why question, how to create value with new technologies and why are these new technologies needed, these questions are related to what I discussed a minute ago, related to transformation and improvement of products and services and business models. So combining these with these new technologies is needed to create value with Industry 4.0. Now, in order to answer these questions, it is necessary to understand what is happening in manufacturing systems. So why are the new technologies needed for manufacturing systems? For products, that question is kind of straightforward. So if you take the example of an autonomous vehicle, how to build an autonomous vehicle, we know that it is quite complex, it is quite random, and there are lots of data coming from all the sensors. And the design and control problem is very, very difficult to achieve the desired results. And the desired result in this particular setting is taking one car from one location to another in the safest way possible in the desired time period. So given this objective, given the randomness and complexity of what can go wrong from one location to another, this is an enormously challenging problem. In order to solve this problem, you need technology and you need advanced data analytics and AI methods, and nobody questions why these technologies and data analytics and other approaches that are introduced by Industry 4.0 are needed to design and operate an autonomous vehicle. In the manufacturing systems, they have been quite complex since the very beginning, and they are also quite random. The data is available now, it is more available with Industry 4.0, but when we look at the design and control task, so far, it has been quite easy to achieve the desired results. So what we mean by the desired results, if you need to produce a given number of cars, so even going back to the assembly line introduced by Henry Ford, so if you want to produce a given number of Model T cars, then although it is random, although it is complex, the data you can use it, given this objective, it was quite easy to achieve the desired result by using heuristics and simple rules. So if a manufacturing system is operating in a way that it is possible to achieve the desired results, then investing in this Industry 4.0 type of technologies may not be needed. But what is happening now, which is quite different than the time of the assembly line in 1910s, is that it is quite difficult to achieve the desired results of cost, quality, time, flexibility, and variety. The manufacturing systems are operating in an environment which is much more challenging compared to the period of 1910s to 20s. So basically what is different is related to the changes in production environment. So if you look at how where the manufacturing companies are operating right now, the customer demand has changed. Now we are talking about rapid and mass customization, more variety, even customizing for the masses by using the manufacturing systems. we are talking about coupling products and services. We are not only talking about, let's say, selling a single car, but we are selling a bundle of product and services. We have many different production technologies like additive manufacturing and others, and they are getting cheaper every day. And with the advances in Industry 4.0 and technology, in communication technologies and so on, we are seeing cooperation and decentralization within the network. So there are many changes are happening. At the same time, the technologies that are introduced by Industry 4.0 also allow companies to affect these dimensions in a significant way. Given these changes, if we like to benefit from these changes, the value creation should come from decreasing the time to value creation, increasing flexibility, and increasing efficiency. These three items are the main challenges and opportunities in industry. So basically, the time to create value, in flexibility, efficiency. So if we can produce faster, in a more customized way, more flexible, cheaper, in a better quality, in a more efficient way, less costly, in a more sustainable way, then basically we will be able to address the main challenges and opportunities introduced in industry. So it is not an easy task. So compared to the former times that the challenge of manufacturing systems was not there, addressing these kind of changes is basically what is driving Industry 4.0 in manufacturing systems. So as the desired results get more complicated to achieve, now you need technology, you need data analytics, AI, and all the other technologies introduced by Industry 4.0. So that is basically the answer of why these technologies needed for the operation of manufacturing systems. You can also look at it from a different side. So if an investment in an Industry 4.0 related technology is not decreasing the time to value creation, if it is not increasing flexibility, if it is not increasing efficiency, and if it is not achieving one of the items listed on the right-hand side, then you can question the return on the investment of these technologies. So you should always try to link the outcome and the investment in these technologies in order to see that. So going back to the value creation with Industry 4.0, so basically we had the value creation with Industry 4.0 is related to digitalization and integration of vertical and horizontal value chains. So there is a value chain component, there is the product and service component, and you also have the business model component. So before going into the technologies, you need to connect this value creation with the ideas of revising, transforming, improving value chains, transforming, improving products, and transforming the businesses by using new business models. In this kind of a setting, data analytics become the core capability, and in this way, you can combine the technologies with the objective of value creation. Now, after this discussion of value creation by using Industry 4.0, I can also introduce my research topics in a nutshell, how they fit into this kind of a framework. So I have been working on data analytics as a core capability in terms of different methodologies related to data and analytics. So my expertise is in data analytics, decision analytics, stochastic modeling, control, simulation, optimization. So you can think about this as the data core capability or methodology related research. At the same time, I am also talking about working on using big data analytics and advanced algorithms for data-driven control, energy control, inventory optimization, procurement, and product feature selection. Again, this is basically related to big data analytics and advanced algorithms. A part of my research is also related to data-driven modeling and digital twins, which I will talk briefly today, and also related to transforming and improving value chains by using network organizations and cooperative networks. So this cooperative networks, the concept of using networks for cooperation of independent companies has been around for a long period of time, and I've been working on this area for a long period of time, but the technologies introduced by Industry 4.0 actually made it possible to make these kind of networks operate in an efficient way. Now, not only you need to develop this kind of methodologies or structures and use methodologies to improve that, you also need to think about the business models so that they work in an effective way. So a part of my research is also related to developing business models and especially cooperation-based business models. So what I would like to talk in the remaining part of this presentation is looking at this picture, but I am going to talk about two topics. One is the data-driven control, how we can create value by using data-driven control. And in the second part, I'm going to talk about the concept of cooperative networks by giving some examples of cooperative networks related to some of my earlier work. Now, the design of control of production systems is consisted of designing the products, processes, system architecture, selecting the machines, buffers, and operating policies for given requirements related to cost, quality, time, flexibility, and variety. The design of products and the processes, if you leave them out, you can look at this concept of how can I design a manufacturing system so that I achieve the desired cost, quality, time, flexibility, variety objective has been around, has been a topic of research for probably 40, 50 years. Now, the basic idea is quite simple. So you want to meet the demand, you want to meet the due date, you want to lower the cost, and especially nowadays, you want to make it more sustainable. The difficulty comes from the need for robustness. Uncertainty affects us. We have supply chain disruptions, we have machine failures, we have variability of demand, we have unexpected things affecting the performance of a system. So the question is, how can you design and control a production system to have a robust operation and efficient operation and effective operation at the same time? And the Industry 4.0 and the technologies available within this umbrella term allows us to do it in a better way compared to the previous years. What we mean by data-driven performance evaluation and control is related to this topic or term of digital twins. Digital twins has been, digital twins term has been around for a long period of time. What we are talking about is looking at a production system, collecting the data, having a digital model of the production system, use this model for designing or controlling the system. This has been around for a long period of time. Now, sometime earlier, we also started feeding this digital model and updating its parameters by using the real-time data from the system. So basically, when you do that, then your digital model becomes a digital shadow. in industry, actually in manufacturing systems, in most of the time, what they refer as the digital twin is a digital shadow. What it means is that it is shadowing what is going on in the production system real time. It is a good start, but it is not the only way to create value by using this technology. What you need is actually controlling the production system effectively based on the observed data. Only when you have this connection from production system to digital model and from digital model to production system, then you can have a digital twin. So not only it is sufficient to follow what is going on in the production system in real time, but you should be able to use this real-time data to control the production system. I will talk about what I mean by control. So in order to do this in an efficient way for predictions about the future, then you need certain approaches for models. So models that will allow you to predict the performance of the system based on either some analytical models or simulation, or a combination of the simulation and analytical models. So a part of my research has been developing this kind of fast and accurate performance evaluation tools that work directly with the data collected from the system, so that you can evaluate the performance of the system about the future performance and using these models for design and control. So the idea is using the data and then using this data for performance evaluation. This is an example of a semiconductor manufacturing value chain, a supply chain of Bosch company. In a European project, Productive 4.0, our task was developing a system to evaluate the performance of the system based on the data collected in real time. So basically, given the real-time data, the question is, how can we build a data-driven model of this system so that you have real-time performance evaluation about time to create value, about the flexibility, about the effectiveness of certain decisions. Now, this is the performance evaluation part. You can also use the data collected from the system to make real-time production and release decisions. What we mean by production and release decisions is you have to decide when to produce, when not to produce, when to introduce a particular lot into a particular part of the system and when not to introduce. And you should do it in a dynamic way, because the performance of the system is changing depending on these unexpected events. When you combine these, we refer as a cyber-physical system. So in other words, you have the physical system, but by using these data-driven modeling and controlling approaches, we have a cyber-physical system that allows you to predict what will happen next based on the data collected in the system. And by using that, you can actually control the future operation of the system based on this data. So if you can combine this with the real system, then you have a way of creating value. Again, the question should be, okay, so we created this cyber-physical system, we have the digital twin and so on, but the question at the end should be related to whether this cyber-physical system allowed us decreasing the time to value creation, allowed us increasing flexibility or efficiency. So at least it should be, a cyber-physical system must be useful for these kind of objectives. But that is what I mean by the data-driven performance evaluation and control. In recent years, actually quite recently, I also started extending this approach of data-driven control to energy control. So basically, why I extended the energy control is obvious today. energy has been quite important for everybody because of sustainability reasons so far. Because if you look at the world share of production and industrial establishments in energy consumption is close to 50%, and 38% of the greenhouse gas emissions are coming from manufacturing related activities. Same for many other countries, including Turkey as well. So, but especially in this period, the energy prices are increasing so much, and the energy resilience has become such an important topic. Controlling the manufacturing system by using the technologies introduced by Industry 4.0 has become a very important topic. So the idea is, if we have a production system, and if you think about different machines that can operate in different energy modes, like a standby mode or an off mode or an on mode, depending on the flow, depending on the service level and throughput, given the connectivity of these machines to the communication network introduced by this Internet of Things platforms and communication platforms introduced by Industry 4.0, if I can change the energy mode of the machine in real time based on the data collected from the system, I can save lots of energy. So basically, the previous results show that even simple heuristic rules of controlling the energy mode of the machine can save up to 30% of the energy in energy-intensive manufacturing industries. So answering the question of value creation by using Industry 4.0 for energy control purposes is quite straightforward, and it will be an important topic. So I have a research project right now, and we are working with Ford Automotive Factory to try these ideas and controlling the machines and based on the data collected, so that the energy is saved, which is good for the industry, good for the environment, but also an effective way of decreasing costs and achieving resilience. So now this data-driven energy control is not only cost and environmental benefits, but it also has achieving energy security, because if you save, you won't need as much energy. So that kind of value creation by using the technologies is quite apparent in this particular setting. Now, in the last part of my presentation, I'm going to talk about cooperative networks and topics like cloud manufacturing. Again, it is a combination of different kind of structures related to value chains and improvements in value chains, which also requires cooperation-based business models to be introduced. And we can do that, again, as a result of the technologies introduced within Industry 4.0. So the topic of competition, network organizations in management literature has been around for a long period of time. But now, today, with the technologies introduced with Industry 4.0, this has become a kind of an effective strategy for manufacturers to come together and produce together and create value together. What I mean by cooperation of independent firms, cooperation of independent firms allows them to benefit from an opportunity in a market that neither of the firms can exploit on its own. So in other words, it is different than mergers, which is you have a formal union of the companies. Here we are talking about independent firms coming together for a period of time, and if they come together if it works for them. So it's a loose kind of relationship. Now, if you can have a structure for the firms to come together, then their different activities in the value creation from purchasing to production and distribution and sales, and you can do that all together. So if you can convince these independent firms to purchase together, to produce together, distribute together, and sell together, obviously there will be benefits. There will be benefits from economies of scale in purchasing. There will be benefits of using the capacity in a more efficient way as a result of pooling the capacity in production. There will be benefits from the optimization of the distribution channels of different companies and assortment pooling in the sales part. So the benefits are quite intuitive to see, but the details are not so intuitive to achieve if related to that. So the details related to how to convince these firms to work together, how to convince them not to share all the information, but only the necessary information so that they work together, how to share the benefits together. All these questions are kind of interesting questions related to that. In recent years, I worked on this concept of network organizations. As I mentioned in management literature, different terms are being used for that, from network organizations to cooperative networks to virtual enterprises, dynamic networks. In recent times, again, with Industry 4.0, the term of cloud manufacturing and cloud services are also being used. My research has been related to developing different methods related to cooperation in purchasing, production, distribution, and sales. Now, this is a project done by Zer Corporation in Turkey, which actually had 4 different companies: Arçelik, Tofaş, Ford, and Koçtaş. Arçelik is the producer of Beko brand, white goods. Tofaş is producing Fiat cars, and Ford is producing Ford cars, and Koçtaş is a retailer. This is their import routes before cooperation. So when they cooperate together and then they look at in their supply chains whether we can cooperate to design these import routes together, and if you design the supply chain network for the joint network organization of these 4 companies, it is quite different than the direct import routes. So you have certain hubs in Europe, and then you bring the goods over there. Maybe then you have larger trucks or train and other or sea transportation. So you can increase the cost efficiency of your logistics activities by cooperation of these firms on logistics activities. In order to do that, you need data, you need communication, you need the technology, you need the optimization, data analytics capabilities, you need the digital shadowing to see what is going on, you need a control tower to solve the problems. But in addition, you need a kind of a business model to convince them that this will work together, which is based on sharing the benefits to be achieved. So that is one example of cooperation in distribution. The last example I am going to talk will be in production. So when we are talking about the production, we are talking about cloud manufacturing. So it's a cooperative network that explores on-demand access to a shared collection of distributed manufacturing sources. This topic has been around for a long period of time, but its effectiveness has been observed only in recent times as a result of the advances in communication technology, in terms of the different kind of approaches that allow these companies to work together, but at the same time by developing different business models that will basically explain how these models work, and when they work, who will benefit, how much benefit will be observed, and how to share the benefits. Now, I've been working on this cloud manufacturing maybe for 10 years or so. Only recently, the number of startups and number of businesses in this area has started to increase exponentially within the last 2-3 years. So especially in Europe, when we look at manufacturing on demand or manufacturing as a service, it is going to increase in coming years, and which is quite promising for small to medium-sized enterprises, and different way of competition with, let's say, low-cost producers, and bringing together the benefits of the expertise of different companies together. Now, working on these kind of business models require questions of how to distribute a given order among different firms. This is not a technology-related problem. So the reason why I'm talking about this example is that the value creation by Industry 4.0 is not only related to the technologies. This is not a technology question. It is a business model question. It is an economics type of question. So you have to find a mechanism. Like in one particular way, in a project, we proposed an auction-based allocation mechanism for cooperation in production. In others, you can also come up with different kind of methods so that these firms find it feasible to work together without sharing lots of information. Now, also, this is another example where we use a cloud manufacturing platform for companies to produce their own products, and their idle capacity is used to produce a store brand for a major retailer. So that combination of using your capacity for your own brand, but also for a store brand, allows them to utilize your capacity in a better way. But then in order to make this work, you need the technology infrastructure, communication infrastructure, but also you need to answer questions related to operation of this network organization. So that is a kind of business model research I've been working on in addition to using the technology. With this example, I would like to conclude the presentation. Basically, I talked about value creation with Industry 4.0 coming from transforming and improving value chains, products, and processes, and also the business models, and using data and analytics as a core capability to combine the technological advances for the value creation. So I gave only examples from data-driven control and cooperative networks, but obviously these are not the only ways of creating value. So basically Industry 4.0 provides the technologies necessary for firms to cooperate on production, logistics, sales, and purchasing, and by doing that, they are adding value. I started my presentation by stating that manufacturing creates the least value, but by using Industry 4.0 that uses new technologies, you can actually increase the value created by all of the steps, including manufacturing. As a result, the value creation with Industry 4.0 is directly linked with this transformation and improvement activities, and it can be through transforming businesses with new business models, product services, but also with the improvement of productivity, products, processes, and customer service. So the Industry 4.0, the technologies are effective for that, but linking them to direct value creation is something we should consider. With this, I would like to conclude my talk. As I mentioned, I wanted to talk about this in general without going into details, and also introduce my two research topics on data-driven control and cooperative networks. If you would like to get more information, obviously, I have publications in these areas, and I can answer your questions in our remaining time. Andrews, let me stop here. So
all right.
If there are questions.
All right, there is questions. So thank you for this insightful presentation. It was real nice hearing you. And we have the first question from Daiva. She's asking, how can companies monetize data? Do you have any examples? And also, what is the role of data for companies in value creation?
Okay, so the data monetization by using data is related to the concept of sharing information. So the sharing information in a supply chain is a topic that has been discussed quite in detail. Obviously, if you think about a retailer, providing the competitor data related to sales to other companies, that might be a monetary value for this data provided. But then it creates different kind of issues, whether they are allowed to share this data or whether it is possible to do that. So I guess the question is not specific to manufacturing, but in general, there are models related to providing data available in a more accessible way. And you can also ask for the value you add to make that data available. So I cannot talk about any examples of in the manufacturing setting, but in other areas, like in retailing, like the market research companies and so on, I think there are examples.
All right, thank you, Barış. Everybody, don't be shy, ask questions. We have Barış for the remaining time. You can write the message or you can ask yourselves. I personally have a questions I wanted to ask Barış. What are some, from your experience, mistakes that companies do when they try to go into this predictive analytics that could have maybe machine learning, maybe simulation together to make their whole supply chain more cost efficient from different perspectives? Are there sort of commonly occurring mistakes that they occur and that you could recommend to avoid maybe?
Okay, so the terms like artificial intelligence and machine learning are too general and sometimes too vague. So obviously, if you are a service provider, you would like to sell your product that is designed to, let's say, increase the efficiency of a supply chain or of a manufacturing firm. But you should, from the buyer point of view, you should be aware that these problems are very complex and you can never be sure about the results of an implementation beforehand. I guess what can work is negotiating the investment partly based on the results. In other words, instead of making an upfront payment for an investment for predictive analytics or optimization, a part of it can be an upfront payment, and the remaining part can be based on the performance to be obtained if you can define that performance in a clear way. And there is always a hype, but there are also some realities as well. So let's say if it is a predictive maintenance or predictive analytics, thinking about the value to be created is also quite important. What kind of improvement are we expecting from this technology, and what is the monetary value for us, and what will it help us so that I can value that investment right now. But what I mentioned about negotiating the initial investment based on performance may solve some of the problems.
All right, thank you, Boris. Yeah, that's a great point. It's really hard to predict, how AI will fit and what kind of results will give you. So if you can negotiate based on results, then that definitely could be very helpful for the company, for sure. Okay, we have another question. Great. What investment of this change could be, and in what terms it could be realized approximately? It's coming from Yulia. So I think, Yulia, are you talking about the whole optimization? Could you be a little bit more concrete? I hope you can hear me. You can also ask Boris a question live if you want to. Yes, so yeah. Yeah, so basically the question is, what kind of investment for this change can be expected, and what terms, probably in time, could they be realized approximately? Probably.
Okay, so if it is related to investments in these AI technologies or others, this topic is referred as performance-based contracts in general. So it is not only for AI, but in any kind of investments, you can think about it as a performance-based contract. So the terms of the contract is based on the desired results within a time period. So it has to be clear of that, and how to share the benefit above the desired level between the two parties. So these are the contract parameters to be negotiated, basically. So there should be an initial payment in order to cover the seller parties' efforts to start the project, but another part should be tied to the observed results, but the performance should be defined quite clearly, obviously. So that is the difficulty in this kind of contracts.
All right, thank you, Boris. Thank you, Yulia. Do we have any more questions? Do you have any live questions? Okay, everybody's shy as always. Okay, so I don't think we have any more questions, so we can wrap this up. I want to thank you, Boris, for coming. I want to thank the guests for coming. I think, it was very insightful. We will put this on our website, on YouTube, so those who had bad connection can go and watch it 1 million times so that we will get 1 million views on this talk. And see you next time on our routine seminars. Thank you, everybody.
Okay, thank you. Bye-bye.